Investigation. Alright, terminating and repeating for prime factorization. This is how you figure out whether a denominator is repeating or terminating. If you see here that 40 is 5 and 2. There are only 5 or 2's allowed in a denominator for it to terminate. It can only be 5 or 2's. See here, it's 5, 2, and 3. There cannot be a 3. There can only be a 5 and a 2. That's why this is repeating.
11 as the denominator in a fraction. If you have the 11 as the denominator, you multiply the numerator by 9. This number is your repeating decimal. For example, if you have 4 over 11, you multiply the 4 by 9, and you get 0.36 repeating.
9 as a denominator. The number in numerator repeats. 2 and 9 would equal 0.2 repeated. 5 and 9 would be 0.5 repeated, and 8 and 9 would be 0.8 repeating.
I'm going to continue off what Logan said about 9's, 2 9's, and 3 9's as denominators. Number of digits in denominator represents a number of digits that repeats. Alright, so if you have a 2 9's and there is 0.07 and it repeats, and for that fraction you're only going to put 7 over 99 because 0 is your placeholder. That's going to, and for 67 over 99 it's going to be 0.67 repeating, and same for this, but it's for 8 point repeating. Now, decimals to fractions. If terminates, read decimal right fractions. So for a terminating decimal, which for instance it's 0.8, which is tenths, it's going to be 8 over 10. And then right here, 0.03, which is 300ths, is 3 over 100. Now, if it repeats, count the digit that repeats. This is how many 9's you need. So 0.72 repeating means you only need 2 9's. For 0.008 repeating, you need 3 9's, but only one number is going to be on the top. Now, 0.047 over 999, there are 3 numbers, but you're only going to have 2.
Rational and irrational numbers all fall under the real numbers umbrella.
Rational numbers are examples of integers are rational numbers. An example of integers are -2. There are fractions. For example, here's 1/2. Repeating decimals are 0.45 repeating. Perfect squares, terminating decimals can be written as fractions.
Irrational numbers cannot be fractions. Irrational numbers do not repeat or terminate, and irrational numbers are non-perfect squares, and pi is also another example of irrational numbers.